Okay, so let's take a look at the definition of absolute value. Like I told you before, if you just think absolute value will just make it positive, then you really don't know that much. This is the definition that, actually looked in your Algebra 1 book, and it's there. This definition is there. It's equal to x when x is greater than or equal to 0, negative x when x is less than 0. It's a piecewise function. So basically, how does it work? Well, look at that. You guys know how a piecewise function works? Okay, let's draw the graph. Some of you going, what? What wise function? Okay, do we know how to graph y equal x? Yes. That's one of the first lines we graphed in Algebra 1, right? Looks like that, but do I draw the whole graph? No, only when x is greater than or equal to 0. So that means starting from here and then to the right. Okay, do we know how to graph y equal negative x? You bet you bippy. That's the second graph we graphed in Algebra 1, right? Do I graph the whole thing? No, only when x is less than 0. That means to the left of the y-axis. So that means it's only this. Now I know pretty much for a fact, most of you, remember your teacher told you just to memorize this graph? And then you have to shift it left, right, up and down and things like that. But see, that's bad to memorize it because everybody just remembers it's a V. Is that you? You just take the V and then you shift it around. But that in upper math, that's not good enough. You gotta know the piecewise function. If you understand the piecewise function, then you understand why it comes out to a V. You don't just memorize, oh, it's a V. I guess you can, but it's only going to take you so far. So how does absolute value work? If the inside is positive, you leave it alone. See how it doesn't change? But if the inside is negative, you negate it. That's how absolute value works. How did Mr. Rubash explain it last year? Something about turning on the thermostat or something? What did he say? I don't know, I just remembered thermostat. Okay, look, if the inside is positive, leave it alone. If the inside is negative, you negate it. So, let me show you how this works. What is the absolute value of 3? Okay, you guys know it's 3, but why? Because if the inside is positive, you just leave it alone. That's why it works. What is the absolute value of negative 4? It's 4, but why? Because if the inside is negative, you negate it. The opposite of negative 4 is positive 4. That's why the answer always comes out positive. You guys understand this? Because if you don't understand this, you're going to have a hard time. Plus, you also have to know the difference between or and and. Okay, so let's take a look at 3 situations. And these are all in the notes, by the way. Absolute value of x equals a. Absolute value of x is less than a. Absolute value of x is greater than a. Okay, let's examine each of these. What does this mean? Here, let's look at a concrete example. Absolute value of x equals 2. What numbers can I plug in for x that'll make it true? Negative 2 and positive 2, right? So plus or minus 2 is the answer. So that's why if the absolute value of x equals a, that means either x equals a or x equals negative a. That's what it means. And of course, or means union, right? It means both of them. If you throw this in a box, you throw that in a box, what's in the box? Both of them are in the box, right? That's why you got to know the difference between or and and. Otherwise, you're going to have a hard time. Okay, what about this one? Let's do a specific number. Okay, if the absolute value of x is less than 2, what does that mean? What numbers can I plug in here to make it true? Like 0, 1, 1.5, 1.8? What about negative 1? Negative 1.9. So what numbers can I plug in for x that will make this true? X would have to be between negative 2 and 2. That's exactly what it means. So this means x is between negative a and a. And then of course the next question is, when you see a chain of inequalities like this, do you guys even know what that means? This means A is less than B, and B is less than C. See the word and there? That means the intersection of the two, the overlap. Okay, and then finally this last one. Let's look at a specific number like that. What numbers can I plug in for x to make that true? Like 3, 4, 5, 6, right? What about -3, -4, -5, -6? Yeah. So what does this mean? Doesn't this mean x is less than -2? Or x has to be bigger than 2? Yep. So. Okay, so these are the three forms that you see. Okay, now this one is easy, although, you know what? I'm going to go over this because, okay, if you saw an equation like this, oh, I can't go to the other side. Boy, doggone it. If you saw this, x squared is equal to 9. Okay, you already know the answer is x equal plus or minus 3. You know why is there a plus or minus?
Because -2 plus -3 is 9.
Okay. Okay, but you know, a lot of teachers, you know, when they show you the steps to solve it, you know what they do? They go, okay, square root both sides, and you get x equal plus or minus 3. So that's why students think the square root of x squared is x, and the square root of 9 is plus or minus 3, but that's two mistakes right there. The teachers are leaving out the most important step. If you square root both sides, what is the square root of x squared? It's the absolute value of x. It is not x. It is not plus or minus x. It is the absolute value of x. Just check any math book. Plus I have it in my notes as well. And then what is the square root of 9? 3. It's not plus or minus 3. It's just 3. Okay, so now the absolute value of what number is 3? It's plus or minus 3. So the reason why there's a plus or minus here is because of the absolute value. But see, when teachers leave out this step, that's why students make these mistakes. So here, I'm going to write it down. This is already in the notes, but I'll do it again. You guys just have no idea how important that is in calculus. The square root of x squared is the absolute value of x. And the difference between getting a 4 and a 5 on the AP exam is you got to know how to handle absolute value. It's a piecewise function, that's what it is. Don't worry, we're going to do plenty of work with absolute value in this class. So if you look at tonight's homework, what you're going to do is you're just going to simply solve inequalities with absolute values in it. Okay, so I'm going to erase all this. Remember these three things now. You know what? I'll leave those up. I'll erase this part here. Okay, I'm going to do examples that look like almost exactly like this, like writing a quiz. We just change the numbers. Okay, 2a and 2b are kind of the same ilk, except one is less than and one is greater than. Maybe I should do both. Okay, how about this? 3x minus 2 is less than 7x plus 1. See how I just changed the numbers? That's exactly. Okay, now you look at this. Now, does that look like one of these three forms here? Look. Absolute value of gorilla equal A. Absolute value of gorilla is less than A. Absolute value of gorilla is greater than A. Does it look like one of those? Yeah. Oh, I forgot to put the absolute value. That's why you guys are confused. Does it look like one of these three? Yeah, the second one. So you just follow the form. What does this mean? You put gorilla in the middle. Oh, I forgot to, you know what? We're going to have to go. Time out. We got to go back. Let's do an easier one first. How do you solve an inequality like this? Absolute value of x minus 3 is less than 2. That's just a simpler version of this. But we need to go over it because it's important. Well, this is it, right? So follow the form. You put gorilla in the middle. Come on, you guys did these from Algebra 1, right? And what do I put here and here? This is on the SAT as well. -2 and 2, right? And then how do I solve for x? Add 3 across the board. So add 3 to that. add 3 to that, add 3 to that, and there you go. Easy, right? Everybody can do that. Okay, but you gotta know more than that. Is there a significance to this number and that number? In SAT prep, we went over this because they actually test you on this on the ACT and SAT. Like if you were to graph this, look, 1, 5, and then everything in between. What do these numbers here have to do with this? Well, what's halfway between 1 and 5? 3. Yeah, that's this number here. And what do you think the significance of this number is? That's the distance from the center to the edge. So this tells you the number in the middle of the interval. This number here tells you how much to go left and right. So if you ever saw this, like let's try to solve it using that method. How about x plus 2 less than 6? So what you do is you think, okay, what number is in the middle? Look, x minus 3, then 3 is in the middle, so x minus negative 2. Negative 2 is in the middle, and then this number tells you how much to go left and right. So if you go 6 to the left, you go 6 to the right, and then it'll be everything in between there. So the solution is x is between negative 8 and 4. Because you're going to have to know that to solve like more high-level problems. Yeah? Because on the SAT, lots of times they give you like, they go backwards. Like they go, okay, let me think. Negative 1 less than x less than 9. They're going to give you 4 answers. Which of the following will give you this as the solution? But then easy, just think, okay, think of the graph, negative 1 to 9. What number is in the middle? Take the average. Huh? Take the average. Okay, 4. Okay, so you would go absolute value of x minus 4, and then how far is it from 4 to the edge? 5. Boom. That's how you pick out the answer on the SAT. But of course, if you don't know that, then what you got to do is you got to solve each of the choices, and then hopefully until you get this one, yeah? Okay, but I'm telling you, in this class, you got to know this. Okay, can I erase? I'll just erase this one. Okay, now we're going to do this problem. So this problem kind of looks like that simple one, except, Mr. Park, I want x on this side instead of just a number. Yeah, and that makes it a little tougher. But you do the same thing. Hey, Mr. Park, it looks like this. I just go follow the form. So you put gorilla in the middle. What do you put over here? Negative banana. And what do you put here? Banana. Just like here. You put gorilla in the middle, and then you put negative banana there and positive banana there. You just do exactly the same thing. But now, here's where it gets tougher. How do you solve for x? See, you can't really solve for x like that one because there's x's here and here. So what you have to do now is you got to use, remember I told you, what does A is less than B is less than C? What does that mean? It means this is less than that. A is less than B. And what's the proper word? And or. Because one of them will give you a fatal error. It's and. So the only way you can solve it is you got to split it up into 2 separate inequalities. Okay, so solve this one. Now, I don't know about you, but I like to put the x's on the left, but every year, I mean, as long as you're not bothered by it, I just like to put the x's on the left for some reason. Divide by negative 10, so x is greater than 1/10. Remember, when you divide by a negative number, you got to switch the inequality sign. Okay, so solve this one. Negative 4x and 3. X is greater than negative 3/4. Okay, so what do I do with this? Well, this and this. It's the intersection where they overlap. Now, can you do that in your head? Or do you need to draw a graph? If you have a hard time, draw a graph. How do you graph x is greater than 1/10? Wouldn't you do this? How do you graph x is greater than negative 3/4? Wouldn't you do this? Okay, so and means where they overlap. The intersection of the two. Where do these two graphs overlap? Really? X is greater than 1/10, and that's your answer. So So that's why. It's a big difference between and or, because if you put an or here, what does or mean? Union. If I threw these numbers in a box, and then I throw these numbers in a box, what's in the box? It would be these numbers, but that's not the correct answer. That's why you have to know the difference between or and. Okay, let's do another example. And that's how you get good at this. You just gotta do problems. Maybe some of you still think, oh, I just gotta memorize some things before the quiz and get an A like last year, but I don't think that works anymore. Okay, let's do a problem like C. What happens when you have absolute, no, okay, I'll do that. No. I'm gonna do a problem like E first. Absolute value, but then we have a fraction. How about x over x plus 1 is greater than 2? And let's put a 3 there. See, that's how I make my quiz. It kind of looks like E there. Except I made instead of less than, I put greater than. I changed the numbers. Okay, so what do I do? Does this look like one of the 3 forms here? Yeah, it looks like this one. See? Absolute value of gorilla is greater than banana. That's what that is. So then you just regurgitate. What does this mean? Oh, I erased one of them. This means, okay, here's gorilla. So what does this mean? Gorilla is less than, follow the form, negative banana, or gorilla is greater than banana. Follow the form. Now, do you know how to solve this? Yeah, this was last night's homework. Do you know how to solve this? Yes, this was last night's homework. Do you know what or means? Yes, so then you can solve the problem. Okay, how do you solve this? This is last night's homework. Should I multiply both sides by x plus 1? No, because that would be a fatal error. So what should you do? Make one side 0. Then you make a least common denominator. So that simplifies to, why am I getting so winded? Okay, you get that now. I'm just going to grab it over here. Okay, how do you grab this? What do I put in my number line once you have it all factored? Hello? Did you guys do last night's homework? -1, one makes the top 0, -2 fits. They're both not part of the solution. And how do I know, after doing last night's homework, I don't even have to think. How do I know it's going to be plus, minus, plus? Because the leading coefficients are positive, so you know the one down here is going to be plus. And how do I know they alternate? Because they both have odd power, right? That's what you got out of last night's homework. Okay, now and then what are we looking for? We're looking for less than, so we shade in the minus sign. Okay, now you do the same thing with this. So Mr. Park, could be a lot of work. Yeah. It's very mechanical. You just grind out the algebra. Make one side 0. Least common denominator. And please distribute that minus sign every single year. If you don't distribute that minus sign, you might get like an unsolvable thing, you know. So that comes out to x minus 2 all over x plus 1. That's pretty nice. Okay, so let's make a number line for that, but stack them on top of each other. Okay, so what goes on the number line? -1 and 2. No and no. And again, how do I know it's plus minus plus? Here. Okay, and then since it's greater than, we're going to shade in the plus signs. Okay, so this is the solution for this one, the left one. This bottom one is the solution for this, but now we got to put them together with or. It's union. What is union? If I put these numbers in a box, and I put these numbers in a box, what's in the box? From negative infinity, that's an ugly infinity, to -1, and then what? Really? -1 to -2 fits, and then 2 to infinity and beyond. What if there was an and there? What if this was an and? Then it would be where they overlap. Well, if you look at this and this, where do they overlap? They don't, so the answer would be no solution. But that's not what we have. We have or here. Okay, we gotta do 2 more examples and then we can go to lunch. Although it's not really lunchtime yet. Okay, now what happens when you have 2 absolute values? Like look at problem C. Okay, also I'll do a problem like that. How about x plus, let's use different numbers. X plus 2 is that 2x minus 3. What do you do? Does this fit any of those forms there? No, so what do you do if it doesn't fit any of the forms? Then you rely on the definition of absolute value. And what is that again? Because actually, if you know the definition of absolute value, you don't even need to memorize these 3 forms, because you can always use the definition. But it's a lot faster if you do, because you're going to see how much work you're going to do for this problem here. So, if you see 2 or more absolute values, then you probably want to do this method here. It's called the number line method. Okay? So, what numbers do I put in the number line? Well, here's an absolute value. What makes the inside 0? Negative 2. Put that on the number line. Here's an absolute value. What makes that 0? Put that on the number line. I'm going to move it a little bit because we need room. Now, is negative 2 part of the solution? In other words, if I plug it in, does it come out true or false? Come on, this is plugging in numbers. My dog can do that. Plug in negative 2. Plug in negative 2 there. 7. Is 0 less than 7?
Yeah.
Wait, let me get my calculator. Yes, it is. It's true. Okay, plug in 3 halves. Really? 7 halves is less than, plug in 3 halves, 0. Is 7 halves less than 0? I don't think so, so that one's false. Make sure you get these points down first, because that's like -1 for each one, you know. Okay, now we're going to use the definition of absolute value. What does that mean? If the inside is positive, you leave it alone. If the inside is negative, you negate it. Okay, it doesn't matter which region you do first. I just like to do this sometimes. Think of a number bigger than 3 halves. 2. Okay, 2 plus 2 is positive. If the inside is positive, you leave it alone. Okay, plug in 2 here. 4 minus 3 is positive. So if the inside is positive, you leave it alone. That's how you do absolute value. It's 50-50 chance. Either you leave it alone or you negate it. Now solve this. Negative x is less than negative 5. X is greater than 5, right? Now, how do you graph x is greater than 5 only here? Because this inequality is only valid here. How do I graph x is greater than 5 only right here? Well, you put a 5 on the number line and then greater than, so you go to the right, to the right. Boom. Okay, but that's just one. We've got to do 2 more. Okay, are you guys following? Hopefully by the time we get to the 3rd one, you get it. Okay, think of a number between negative 2 and 3 halves. 0. Okay? 0 plus 2 is positive, so you leave it alone. 0 minus 3 is negative, so you negate it. You guys know what negate means? Multiply by -1. Okay, and then you simply solve that. Come on, this is less than algebra 1 right here. X is less than 1/3. So you graph this only here, because that's the only time it's valid. So how do I graph x is less than 1/3 right there? Put a 1/3 on the number line and less than, so go to the left, to the left. Because every year the students are going the wrong way. Greater than means that way. Less than means this way. Okay, we got one more region over here. Think of a number smaller than -2. -3. Okay, -3 plus 2 is negative. So what am I going to do? I'm going to negate it. See, either you're going to negate it or leave it alone. That's the only 2 choices. And how do you determine if it's positive or negative? Okay, if I plug in -2 here, you're going to get -7. That's definitely negative. So what do I do? I negate it. Oh, I get it, Mr. Park. Like over here, I left them both alone. But then this one, I leave this one alone but negate that one. And then when I move here, now both of them are negated. Yeah, so every time you move one of them is gonna change. Maybe that's what Mr. Rubash meant by the thermostat. I still don't get the thermostat thing. Anyway, x is less than 5. How do you graph x is less than 5 only on this interval here? It would be the whole thing, that's right. Some of you going, what? Because how do you graph x is less than 5? You put 5 on the number line, which is here, and then you go to the left like this. But you're only graphing it here, so therefore it's the whole thing. Okay, so now to get your answer, you stand back and you look at this, whatever's on your number line, that's the answer. So your answer is going to be x is less than 1/3 or x is greater than 5. That's your answer. This is called the number line method. This method works on everything. But then, like I said, would you really want to use the number line method on this? Because if you did, then you would have to solve 3 of these. Some of you had enough time just doing 2 of these, right? So you gotta pick and choose. So here, this is the general rule of thumb. If you see 2 or more absolute values, that's what you do, number line method. Everything else, just follow the form. Okay, no question. Oh yeah. Okay, so last thing. Now, what if I allowed you a calculator on the quiz? How would you solve this? Let's erase. Because remember, if you have a calculator, you can solve any equation or inequality on it, right? This is an inequality. So what? What did I teach you? How do you solve any equation or inequality? You make one side 0, like that, and then you graph this on your calculator, and then what do you look for? What does less than 0 mean? Where is the graph below the x-axis, right? Okay, so here, I will take out my calculator. Can you guys do it on your iPad? Where's the calculator? HP calculator there. Okay, so go to symbolic. There. Okay, do you guys know how to get absolute value? I think it's in your templates. You know the template button, this one here? The one that's above the cosine? If you press that, I bet you one of these is absolute. Oh, right there, the lower left-hand corner. Absolute value of x plus 2 minus, template button again, absolute value, lower left-hand corner, 2x minus 3, 2x minus 3. Okay, enter. Woo! Okay, now let's graph it. Plot, set up. Remember, how do you get the default settings? Don't you just press shift clear or something? Yep, there you go. Okay, now I'll press plot. Boom. There's the graph. Now look at this graph. Where is this graph below the x-axis? Well, it would be to the left of that right there. How do I know what that is, Mr. Park? Yeah, find the root, and it's going to be 1/3. You would see 0.33333. You can guess that's 1/3. So x is less than 1/3, and what's that right there? That's 5, right? X is greater than 5. You can solve any equation or inequality on your calculator by simply making one side 0 and graphing it. That's like one of the most important things you're going to learn this year, because you're going to use that until your math career is over. We do that in calculus. We do that in multivariable calculus. You got to be able to use your calculator to solve equations and inequalities. Okay, any questions on this? No, it's not that difficult. You just have to practice it. Like this number line thing, it's very mechanical, right? You just got to ask yourself, is it positive or is it negative? If it's positive, you leave it alone. If it's negative, you negate it. That's what you do. All right, this class ends at 12, yeah? 3 minutes to spare. All right. We will see you on Monday. And don't forget, we have a quiz on, what is it called? Binabsineq 1 and 2.